What if I told you that all the planets in our solar system are merely Earth in different stages of its evolution? It's a mind-blowing concept, isn't it? This is the essence of the Uniplanetary Evolution Theory, an intriguing conclusion that draws fascinating parallels between Venus, Earth, and Mars. Let's start with Venus, often referred to as Earth's twin due to their similar sizes. However, the resemblance runs much deeper. The current state of Venus could be a snapshot of Earth's past. Picture this: a thick atmosphere dominated by carbon dioxide, leading to an intense greenhouse effect. Sounds familiar? That's because Earth, during its early Proterozoic era, had a similar atmospheric composition, thanks to volcanic activity and off-gassing. And speaking of volcanoes, Venus is a hotbed of volcanic activity, boasting large volcanic plains and towering shield volcanoes. This mirrors ancient Earth during the Archean and Proterozoic eras, when volcanic activity was a key player in atmospheric changes and land formation. Now let's turn up the heat. Venus's surface temperature exceeds 450 degrees Celsius. Ancient Earth also experienced high surface temperatures due to a mix of greenhouse gases and volcanic activity. This extreme heat was instrumental in forming and sustaining the geodynamo, which in turn gave birth to the electromagnetic field that we rely on today. Moving on to the atmospheric pressure. Both ancient Earth and present-day Venus have had periods with dense clouds and high atmospheric pressure. On Venus, the atmospheric pressure is about 90 times that of Earth, comparable to Earth during periods of heavy volcanic activity. Finally, we see evidence of tectonic-like activity on Venus, indicating some deformation in the planet's crust. This resonates with ancient Earth, which was also tectonically active and showed early signs of continental drift and tectonic processes. As we dive deeper into this comparison, remember, Venus could very well be a glimpse into Earth's past. This is just the beginning of our planetary evolutionary tale. Stay tuned as we venture to Mars and further explore the Uniplanetary Evolution Theory. Now, as we gaze into the future, we might see a reflection of Earth in Mars. Much like Earth, Mars holds a complex geological history, weather patterns, and a host of features that suggest it could have supported life in its past. Let's wind back time and imagine Mars, with liquid water carving its surface, shaping the environment much like it does here on Earth. The red planet bears the scars of this past, with the remnants of dried riverbeds and ancient lake basins etched into its surface. There's even evidence to suggest that vast oceans once spanned across Mars, much like our own blue planet. Now, picture the poles of Mars, capped with ice, not unlike the frosty ends of Earth. These Martian polar ice caps are mainly composed of water ice and yes, even carbon dioxide ice, a chilling mirror to our own polar regions. But it's not just in the solid and liquid states that Mars mirrors Earth. The tilt of its axis results in seasonal changes, similar to our own. Although Mars experiences more extreme seasons due to its elongated orbit, the cycle is familiar. And what about a day in the life on Mars? Well, a Martian day, known as a sol, is roughly 24.6 hours long, close enough to our own daily cycle to feel almost homely. Yet, Mars is not a carbon copy of Earth. Its atmosphere is thin, far less dense than our own. But even so, Mars exhibits its own weather patterns, with wind and dust storms sweeping across its surface, and seasonal variations that mimic those of Earth. The geological history of Mars is as layered as the strata in its ancient rocks. It reveals tales of volcanic activity, tectonic movements, and sedimentary processes. These are stories we know from our own planet, further binding Earth and Mars together in their shared history. Mars, with its complex geological history and evidence of conditions once favorable for life, could well be a glimpse into Earth's future. It's a sobering thought, but one that brings into focus the importance of understanding our planetary neighbors. After all, by looking to Mars, we might just be peering into a crystal ball, revealing the possible future of our very own Earth. Mars, with its complex geological history and evidence of conditions once favorable for life, might just be a peek into Earth's future. So, what does this all mean? Enter the Uniplanetary Evolution Theory. This intriguing notion suggests a clear progression among the celestial sisters of our solar system, Venus, Earth, and Mars, much like the sequence of 1, 2, 3 or the ordered progression of ABC. Our story began with Venus, a scorching volcanic world mirroring Earth's fiery infancy. Earth, our home, represents the here and now, a thriving oasis of life teeming with diversity. Yet the specter of Mars looms as a potential glimpse into a distant, colder future. The Uniplanetary Evolution Theory posits that each planet is simply Earth at different stages of its life cycle. Venus, our past, Earth, our present, and Mars, our possible future. It's a compelling perspective that breathes a sense of unity, progression, and dynamism into our understanding of the solar system. Next time you look up at the night sky, remember, each planet might just be Earth at a different stage of its evolution. It's a cosmic dance, a testament to the ever-changing nature of our universe. If you are a passionate explorer of the mysteries in our cosmos and eager to uncover new perspectives, you've come to the right place. We post thought-provoking videos every day, so don't miss out on any of our mind-blowing episodes. Hit that subscribe button now and embark on more awe-inspiring voyages of discovery.